All right. Let's start with number 1. Okay, let f and g be functions given by 1 plus sine 2x and e to the x over 2. Let R be the shaded region in the first quadrant enclosed by the graphs f and g in the figure above. Anytime we're dealing with trig, you want to make sure you're in radian mode, so we should always just be in radian mode to begin with anyways. Okay, part A, find the area of R. Top minus bottom is going to be pretty straightforward. However, we just have to be able to know how to find those intersecting points. So zoom 6 just so I can get some idea as to where this graph is going to look like. Right, so it's a really, really tiny region in here. I'm going to use Zoombox, Zoom 1. To zero in on that little region there.
Yeah.
Yes.
We can't see anything on the teams.
Oh, really?
Yes.
Amara, are you not seeing on the screen as well? I'm sharing the screen. Let me try again.
That works. I can see now.
Okay, great.
Thank you.
Mm-hmm. Oh, my bad. Sine of 2x, not x over 2. Okay, so there's my region there. If I do second trace, intersect. Make the graph pick points near the intersection and then let it find it for you. So if you see that strange number there, 1.46 times 10 to negative 5, negative 15, that's just another way of saying 0. You wish they would just, it's a really, really small number. So if you see that, if you don't recognize it, just understand that it's basically 0. Okay. Yeah, you wish that they would just round to 0 so it doesn't seem confusing. Okay. Second trace, intersect. Pick points near the other intersection. 1.13. I'm going to go ahead and write those full order pairs there. We may need it. We may need the y values later. I should have done the x as well. You're 1. Okay. Okay, area. Area, just top minus bottom. Top graph is the F, bottom graph is the G. Okay, we're stacking these vertical rectangles from 0 all the way over to 1.136. Okay, enter that in the calculator. You should get 0.429. Okay, find the volume of the solid generated when R is revolved about the x-axis. Okay, we can expect this to be washer method because this is not up against a flat surface. We need two radius, one radius that extends from the axis to the furthest boundary, and the other one that extends from the axis to the closer boundary. Big R, little r. Big radius, top minus bottom. The top is sitting at the F, the bottom is sitting at the 0. Little r, the top of the small radius is sitting on the e to the x over 2. Bottom is sitting at the 0. You can basically drop the zeros because it's not going to impact. Okay, this sorry, washer method. Same bounds as before. We're stacking these circular disks from this end all the way to this end. So from 0 to 1.136. Big radius squared. Minus little radius squared dx. Okay, questions so far? Okay, region R is the base of a solid. For the solid, the cross section's perpendicular to the x-axis. Okay, so x-axis is this way, perpendicular, still vertical, right? Mm-hmm.
For B, I somehow got 1.358.
Let's see. Oh, yeah, you're right. Yeah, 1.358. My bad. Thanks. Okay, base is top minus bottom. Okay, so there's our base. We want semicircles. So semicircles, area is pi over 8 base squared. So all we're going to do is we're going to insert that expression into there. Okay, so once you have your area expression, now you can put it into the volume formula. Okay, so we're just basically just always inserting area between the integral notation so that it can accumulate the area over to give it that third dimension. And bounds are still the same, 0 to 1.126. Okay, so a lot of different variations you can do. You can leave that pi over 8 out in front if you like. Or you can multiply everything through, or multiply the 8 through and leave the pi alone. So it's really, it's up to you. Okay, it's the only time that cross section is going to have a pi involved. Okay, number 2. Let me draw the graph for you here. Let me see. Equals 2. Okay, so it doesn't seem like it's bounded, but it's going to be, this whole thing is going to kind of close up here. Let's see. Yeah, sorry. I thought this was asymptote there. This is actually going to close up right here. Okay, so on the test, I'll give you that shaded region there. Okay, find the area of R. We first have to find its intersections, so we can set the two equations equal to each other, or make the calculator find those intersections for you. So -3, if you do that again, it'll be -3 and 3. Okay, top minus bottom. Top is the 20 over 1 plus x squared. The bottom is the 2. Okay, area, so it's just unit squared. Okay, volume of the solid generated when R is rotated about the x-axis. Again, Washer method. Top minus bottom, top is the curve, and the bottom is the zero. Here, the top of the little radius is sitting at 2, the bottom is sitting at 0. Okay, again, semicircles, perpendicular to the x-axis. So here's the x-axis, perpendicular, again, vertical. Okay, base. Okay, put into your area formula. I'm sorry, -2. This is 0, this is 2. All right, top of the base is sitting at the 20 over 1 plus x squared. The bottom is sitting at the 2. Now volume formula. So here, you don't have to hold on to the pi. If you want to multiply everything through it, that's fine. Or you're going to hold on to the pi, it's 55.471 pi.
How do you get it to be squared within the parentheses on the calculator? TI 8.1. can use both of them. And like outside of the parentheses.
Right, yeah, you're gonna have to create a new set of parentheses.
Okay.
Or you enter this under y1 and then square it.
Okay.
That way you don't have to use as many
Do I just do
parentheses.
2 sets of parentheses within it?
Yeah, you can't, yeah, for some reason, those parentheses under math 9 is built in, and you
Okay.
can't put anything outside of it. Yeah. So it's not falling off.
Yeah, like it just did. It took like 2 minutes to do it. I mean, I gotta wait on it.
Yes.
I got a different answer.
Okay. Yeah, so we need to multiply this by pi by 8. Or you can just divide by 8 and leave the pi. All right, number 3. Okay, y equals square root of x. X over 3 is kind of like a, it's just a linear graph. Okay, area will be top minus bottom. We can find the intersections by using your calculator, or you can solve this by hand. Okay, part B, find the volume. Rotate it around the vertical line, x equals -1. So vertical axis of revolution here. Okay, vertical axis of revolution. First of all, is it the disk or washer method? Washer, right? Touching the shaded region is not good enough to be this method, right? It's got to be up against a flat surface. If you see any sort of a gap, it's still going to be washer method. Okay, we have to draw 2 radius, big R and little r. Okay, if you see a horizontal radius, what does that tell you that we have to do? Yeah, these equations are not built for right minus left. So we can't use these equations, even though it feels easier, it wouldn't be correct, right? So we have to solve for x for both these equations. Hey, our big R is right minus left. The right endpoint of big R is sitting at the linear graph, 3y minus 0. Okay, little r, sitting, right endpoint is sitting on the curve, the y squared, so it's the y squared minus 0. Okay, our bounds as well. We know we can't use 0 to 9. We have to figure out what that highest y value is. You can insert 9 into either equation to get the y value. Square root of 9 is 3. I can put in the 9 in for x. 9 over 3 is 3 as well. So we're looking for that y value, that 3, right? We're stacking these circular rings from 0 all the way up to 3.
Yeah, will the axis resolution be x equal to -1?
Oh, my bad. I messed up. I thought it was at 0. My bad. Let me do that again.
That's right.
Sorry. So what you guys got? Okay. Hey, part C, region R is the base of a solid. For the solid, cross sections are perpendicular to the y-axis. So here's the y-axis perpendicular. That's going to be horizontal. We want to build squares. No pi involved here. There's no circle here. We're building squares. We don't put pi in front. We only put pi in front if it's semicircle for cross section, or if it's disk or washer method. Okay, we didn't get to number four, but I will be sure to put that on the answer key. So if you want to work through it on your own, you can check your answer there. Okay. All right. Thanks, guys.